Welcome to Conspiracist. Today, we're embarking on a deep dive into something really out there, a proposition that's quite mind-bending. The idea that governments, perhaps globally, might have intentionally concealed evidence about parallel universes.
It's a fascinating, if speculative, idea.
Absolutely. We know there are scientific theories, proper scientific theories, that hint at realities beyond our own. So our aim today is to explore the reasoning behind these claims of a cover-up.
Right.
And we want to do this professionally, objectively. No sneering, no dismissal, just look at the ideas.
Sounds good. Where should we start? Maybe with what we actually mean by parallel universes in science.
Yes, good idea.
Yeah.
Because it's not quite like the sci-fi movies, is it? With slightly different versions of us running around.
Not exactly, no. Well, that's a fun trope. Scientifically, we're looking at theoretical frameworks suggesting whole other universes outside our observable cosmos.
Okay, so outside what we can see or interact with.
Potentially. They might exist, alongside ours in some higher dimension, or just be incredibly distant, far, far beyond our cosmic horizon.
And it's not just one idea, right? There are different models for how this multiverse might work.
Precisely. Multiverse is an umbrella term. One big source is cosmic inflation theory.
The rapid expansion just after the Big Bang.
That's the one. And a version called eternal inflation suggests that maybe this expansion never truly stopped everywhere. It's still happening, constantly budding off new bubble universes.
Bubbles, like self-contained universes.
Sort of, yeah. And crucially, each bubble might cool down differently, maybe end up with its own unique set of physical laws.
Wait, so physics itself might not be universal? The rules could be different elsewhere?
That's a major implication, yes. String theory points towards something similar.
String theory, the theory of everything, or trying to be.
Trying to be, exactly. It needs extra dimensions beyond our usual 3 of space and 1 of time.
Right, I've heard about that. Tiny, curled-up dimensions.
Kind of. And how those extra dimensions are shaped or compactified could determine the fundamental constants and particle types in a universe.
So, like your paper analogy earlier, same basic stuff, different outcome depending on the configuration.
That's a pretty good way to think about it. Lots of possible configurations, potentially lots of different universes allowed by the theory.
Okay, that's a lot already. And then there's quantum mechanics throwing another wrench in the works.
Or perhaps providing an explanation. It depends on how you interpret it. The many worlds interpretation or MWI.
This one sounds wild.
It is quite radical. Standard quantum mechanics talks about possibilities collapsing into one reality when we measure something.
Yeah, the particle's either here or there, but not both once you look.
MWI says, forget the collapse. Every time a quantum system faces multiple possibilities, the entire universe splits.
Split.
Into multiple copies, one for each possible outcome. So in one universe, the particle's here, and in another newly created one, it's there.
Whoa. So every quantum event creates branching realities, billions of times a second.
According to the MWI, yes, all possibilities are realized, just in different parallel universes. It avoids some tricky conceptual issues in standard quantum theory, like randomness and spooky action at a distance.
So it's an interpretation designed to make the math cleaner, in a way.
That was part of Hugh Everett's motivation, yes.
Yeah.
He argued the math itself pointed to this. If you took the core equations literally without adding a separate collapse rule.
Okay, so we have inflation potentially making endless bubbles, string theory allowing different laws, and quantum mechanics possibly splitting reality constantly. That's a lot of ways to get other universes.
It is. And theorists have even tried to categorize them. Max Tegmark proposed different levels of multiverses.
Levels? How does that work?
Well, level I is maybe the simplest. If space is truly infinite, then just by chance, somewhere far beyond our observable horizon, there must be regions identical to ours, even regions with identical copies of us.
The statistics in an infinite space.
Pretty much. Level 2 is the eternal inflation idea, bubble universes with potentially different physical constants, different dimensions maybe.
Okay.
Level 3 is the many worlds idea we just discussed, branching realities based on quantum choices. And level 4 is maybe the most abstract.
Go on.
It suggests that all mathematically possible structures exist physically. Our universe is just one specific mathematical structure that happens to be complex enough to contain self-aware beings like us.
That sounds philosophical almost, like math is reality.
It blurs the lines, definitely. Tegmark calls it the mathematical universe hypothesis. It's sometimes framed as the bird's eye view of all possible realities versus the frog's view from within our own pond.
Okay, my head is officially spinning. But let's connect this back to the main topic. If these theories are out there, why would anyone think governments are hiding evidence of them? What's the supposed motive?
Well, you won't find scientists explicitly writing about government cover-ups usually, but you can infer the reasoning sometimes presented in, let's say, less formal discussions. One major implied reason is societal impact.
Like people couldn't handle the truth.
Something like that. The sheer scale, infinite universes, maybe infinite versions of you, potentially different physics. It could be seen as profoundly destabilizing. It might challenge religious beliefs, philosophical frameworks, our sense of uniqueness, our place in the cosmos.
Yeah, learning you're one of potentially infinite copies might make your Monday morning feel a bit different.
Exactly. It could dwarf everyday concerns. Then there's the potential impact on science itself.
How so?
If it turns out our physical laws aren't the only ones, maybe not even fundamental, but just environmental accidents of our particular bubble, well, that changes everything.
It suggests our current physics is just local bylaws, not universal constitution.
Precisely. That could undermine the perceived authority of current scientific understanding, affect funding, research directions. It's a paradigm shift of the highest order.
And the many worlds idea specifically, with everything happening, that must mess with ideas about free will and responsibility.
Deeply. If every choice you could make is actually made in some branch, what does your choice here even mean? These are huge philosophical questions with potential psychological fallout. A hypothetical reason for caution, perhaps, in the eyes of a concealer.
And maybe just the fear of the unknown. If other universes exist, could we interact? Could something come from them? Even if scientists say it's unlikely.
That's often a background fear, more prominent in fiction, but it could play into a supposed rationale for secrecy, the potential, however remote, for interaction or unforeseen consequences.
Okay, so those are some potential reasons someone might believe there's a cover-up. But what about the science itself? Are these multiverse ideas actually solid?
Now we get to the counter-arguments, and they are significant. The biggest hurdle, scientifically speaking, is falsifiability.
Being able to prove something wrong.
Exactly. A core tenet of science, famously championed by Karl Popper. A theory isn't truly scientific unless there's some conceivable observation or experiment that could show it's false.
And multiverse theories.
Yeah.
They struggle with that.
Many of them do, yes. If these other universes are, by definition, causally disconnected from ours outside our light cone, in different bubbles, different quantum branches, how can we possibly detect them or devise an experiment to rule out their existence?
You can't observe them, you can't interact with them.
Right. So some scientists argue, if a theory makes no testable predictions about our universe, is it really science? Or is it metaphysics, philosophy, mathematical exploration?
That's a pretty fundamental critique.
It is. Critics argue that claiming knowledge about regions vastly beyond our observable horizon, let alone entirely separate universes, is an extraordinary extrapolation from limited data. We only know our observable patch, about 42 billion light years in radius.
We're assuming the rules we see here apply infinitely far away, or even in other bubbles.
That's the implicit assumption in many Level I and Level II multiverse scenarios, and some argue that's a huge, potentially unwarranted leap of faith.
What about the idea that the multiverse helps explain the fine-tuning of our universe? Like why the physical constants seem just right for life?
That's often presented as supporting evidence, yes. The anthropic principle. If there are countless universes with different constants, it's not surprising that we find ourselves in one where the constants allow stars, planets, and eventually us to exist.
Makes sense, like buying a lottery ticket. If enough tickets are sold, someone's bound to win.
But critics push back on this too. They say it's a probabilistic argument, not a direct explanation. And it relies on assumptions about the distribution of constants across these hypothetical universes that we can't verify. Also, invoking an infinite number of unobservable universes to explain features of the one we do see. Some argue that violates Occam's razor. It's not the simplest explanation.
So the simplicity argument cuts both ways.
It does. Intuitions about what constitutes a simple or elegant explanation differ greatly among scientists. What one sees as simplifying unification, another sees as extravagant multiplication of entities.
It sounds like there's a real debate within physics about whether multiverse concepts even count as science.
Absolutely. It touches on the very definition of science in the 21st century. Are we sticking to strict empiricism and falsifiability? Or does theoretical physics, dealing with realms so far beyond direct experience, need different criteria. Perhaps consistency with known laws, mathematical coherence, explanatory power.
So proponents might say critics are being too rigid in their definition of science.
Some do, yes. They might argue that theories like eternal inflation or the many worlds interpretation arise naturally from our best current physics, general relativity, and quantum mechanics, and should be taken seriously as consequences, even if direct tests are currently impossible or very difficult.
It's important to distinguish, though, right? Quantum mechanics itself is incredibly well tested. General relativity, too.
Crucially important. Those foundational theories make countless testable predictions about our universe. It's the specific interpretations like many worlds, or the extrapolations like eternal inflation leading to a multiverse that lack direct empirical evidence and face the falsifiability challenge.
So where does that leave us? Is it science, pseudoscience, or something else?
That demarcation is fuzzy and debated. Popper's falsifiability is a key guideline, but maybe not the only one. Given the current state of things, strong theoretical motivations but no direct evidence and major testing challenges, perhaps speculative science or theoretical exploration is a fair description for many multiverse ideas.
Or maybe just being agnostic about it. We don't know, and maybe we can't know.
That's certainly a very reasonable position, acknowledging the limits of our current scientific reach. Science might simply not be equipped, now or perhaps ever, to definitively answer whether other universes exist.
Which brings us back, finally, to the concealment hypothesis. If these universes are so theoretical, so hard to prove or disprove, maybe even fundamentally undetectable,
then the premise for a cover-up gets shaky, doesn't it?
Yeah. What concrete evidence would there be to conceal if it's all rooted in highly abstract theory and extrapolation?
Exactly. While the ideas might be considered dangerous or disruptive by some hypothetical authority, hiding theoretical physics papers or complex mathematical derivations seems different from hiding, say, alien technology.
It's not like hiding a crashed spaceship. You're hiding equations and interpretations.
Right. And the scientific community itself is openly debating these concepts. The papers are published, the conferences are held. It's hard to see evidence of widespread suppression within the relevant scientific fields.
So the argument for concealment seems to rely more on speculating about potential societal reactions than on actual, verifiable evidence being hidden.
That seems to be the case, based on the available information. The motivation for such a massive, long-term global conspiracy to hide theoretical physics concepts appears weak, especially given the lack of concrete, observable proof for those concepts in the first place.
It feels like the discussion about the multiverse itself, its scientific status, its philosophical implications, is the real story here, rather than a government plot to hide it.
I think that's a fair assessment. The exploration of the multiverse pushes the boundaries of physics and cosmology, forcing us to confront deep questions about reality, knowledge, and the limits of scientific inquiry. That's profound in itself.
It really is. We've gone from inflation and string theory to quantum splits and the very definition of science.
It's a journey through some of the most challenging and fascinating ideas in modern thought.
Well, this has been a really thorough exploration. We looked at the hypothesis of governmental concealment of parallel universe theories, dug into the science inflation, string theory, many worlds that fuels these ideas, and tackled the big challenges, like testability.
It highlights that complex interplay between theory, observation, and philosophy when we're talking about the edge of the cosmos.
Definitely. A lot to think about. Thanks for listening to Conspiracist.